Hello. I haven't greeted you all like that yet. I forgot to do that in the video. That's what I normally do, right? So this time, Jovian planets, which means planets like Jupiter. I'm not sure how Jovian comes from Jupiter. It's got to be a Roman thing. But Jovian planets, the big gassy planets. So I asked you guys in a quiz, how does all the hydrogen get blasted out away from the sun and to where the Jovian planets are, and why does all the rocky material stay close to the sun like the terrestrial planets? All of you put because of the material they're made from. The video specifically said, the notes specifically said, the sun's solar wind, the pressure from the sun pushes the gases, the lightweight frozen cold materials away from the sun and lets the rocky materials stay. The rocky materials have too much inertia to be pushed away. They have too much mass and velocity, which gives them momentum and keeps them from being pushed away from the sun. So you kind of got to watch out for that. It was in the videos, it was in the notes, the information was there. You just had to notice it. And so on that one, everybody missed that one on the quiz. So Jovian planets, big gassy planets. Some of them are mostly hydrogen, some of them are ice and hydrogen. Some of them have solid surfaces plus ice and hydrogen and methane. It just depends. And so there's gas giants and ice giants and Pluto. So we'll talk about that one too. But Pluto is a different case. That's why it was reclassified as a dwarf planet. We'll talk about dwarf planets at the end probably, if I have time. So first we got Mercury, Venus, Earth, Mars, the asteroid belt. Don't forget that the asteroid belt is between Mars and Jupiter. The asteroid belt could have been a rocky planet, but there's too much fighting going on. There's the gravity from the sun this way, the gravity from Jupiter that way keeps the rocks from getting together properly. And there's a great video about how that particular gravitational anomaly works. If you watch How the Universe Works, the episode where they show the moon of Saturn going through the rings of Saturn, it's a really bizarre phenomena. The moon goes through the rings of Saturn, and you would think it would start collecting all that material, the frozen gases and stuff and ice in the rings. The frozen material moves apart, the moon goes by, and that material moves back because of gravitational effects. And it's a really bizarre phenomenon. When you see it, you think that it can't happen that way, but somehow it does. Well, that's what keeps the asteroid belt from becoming a planet, is the two forces of gravity working against each other. And so anyway, asteroid belt, rocky material. Biggest object in the asteroid belt is Ceres, C-E-R-E-S. Ceres is a large asteroid, not as big as the moon, but anyway, it's considered a planetesimal because it's in an orbit that is not cleared of other debris, which is weird because Jupiter is in an orbit that's not cleared of other, but it's a planet. That's one of the qualifications for being a planet and versus a planetesimal. You have to clear out all the other stuff in your orbit. And so at one time, the Earth shared its orbit with another planet called Theia, but then they collided and became the Earth plus the Moon. And so Theia got a little bit smaller when it became the Moon. It was about the size of Mars, but we're going to talk about that in more detail later when we talk about how the Moon formed. So Jupiter is the largest planet in the solar system. It is, if you add all the planets together other than Jupiter, just put all the planets other than Jupiter together, Jupiter is still 10 times bigger. And then the sun is 100 times bigger than Jupiter. So the sun is 1,000 times bigger than all of the planets if you don't include Jupiter, but it's only 100 times bigger than Jupiter. Jupiter is very, very, very big. Jupiter is the reason that we do not get hit by asteroids very often. Jupiter catches all of them. Jupiter's gravity and Saturn's gravity save us from all kinds of horrible things happening on Earth. Without those gas giants, the Earth and Mercury, Venus, and Mars would be pelted by massive objects all the time. But we're not. We don't get hit very often because Jupiter catches them all. That's why Jupiter has 60-something moons. It might be up to 79 now. Jupiter and Saturn both have lots of moons because when these big rocks come past them, or not even close to them, they get caught by the gravity, and the gravity pulls them into orbit or it pulls them into the planet, and then if it goes into the atmosphere, it's just obliterated. The winds on those planets, Jupiter, Saturn, Uranus, and Neptune, are just horrendous, ridiculously fast. The fastest ones are on Neptune. That's 2,000 kilometers an hour, 2,000 kilometer an hour winds. But even at 1,000 kilometers an hour, the wind will shred any comet, asteroid, or meteor that hits Jupiter. And so anything that doesn't become a moon of Jupiter is shredded or thrown off into outer space. It is a great defense mechanism we have for keeping big rocks from hitting the Earth. Jupiter is mostly hydrogen. There's quite a bit of helium, but mostly hydrogen. And we all picture Jupiter is orange and white and orange and white and orange and white stripes with the big red spot. That's not all there is. There's orange stripes and white stripes and orange stripes and white stripes, but then there's blue, and then there's green, and then there's blue. There's some yellow in there. The blue and green come from methane pockets near the north and south pole of Jupiter. Jupiter also has really beautiful auroras. Like we have the northern lights, Aurora Borealis. We have the southern lights, Aurora Australis. Jupiter has much bigger auroras. They're really cool looking. We have satellite images from Cassini and New Horizons and other probes we've sent past Jupiter, Voyager 1 and 2, and you can see these gigantic glowing halos over the northern or southern hemisphere of Jupiter and Saturn. And so Jupiter is, let's see, 10 times bigger than all the other planets together, 100 times, 1/100th times the size of the Sun. Hydrogen, helium, a little bit of methane, probably some ammonia in there, but I don't know for sure. And it's got 60-something moons. I have to go look it up again. I swear to you, I read this stuff before I do the presentations, and then boop, as soon as I hit record, it's gone. Anyway. Then we've got Saturn. Oh, now Jupiter does have rings. They're just very faint. The reason Jupiter's rings are faint is they're being pulled into Jupiter. They're falling into Jupiter, and so they're not easy to see. Neptune and Uranus have rings. They're very faint. They keep falling into Saturn's rings. They're falling into Saturn. They're being destroyed, but they're also being rebuilt every day. So that's a completely different story. And I don't want to go to Saturn yet because Saturn's going to take a while. I got stuff to say about Saturn. Jupiter is the planet that has the largest moon, Ganymede, which is bigger than our moon. Ganymede could be another planet if it wanted to. It is bigger than Mercury. Well, pretty darn close. I mean, Mercury is not much bigger than our moon. Ganymede is the biggest moon in the solar system, and it is orbiting Jupiter. All right, Saturn with the moon Titan and the moon Enceladus. Two really fascinating moons around Saturn, but Saturn all by itself is fascinating. I might not even get done with Saturn today. I mean, I'm already 8 minutes in and I've got so much stuff to say. The rings of Saturn were first seen by Galileo through his improved telescope. He did not invent the telescope. He added lenses and he grinded custom lenses and he made it better. He got like 10 times magnification. That was amazing at the time. Now you can get a pair of binoculars with 60-time magnification if you really want to spend some money. And they're great for viewing the moon. If you want to look at the moon in binoculars, there's a really good way to do it. Just go down to Academy, get some binoculars, look up at the moon, all kinds of fascinating things. So Saturn's rings were first seen by Galileo, and he described them as ears. They were these fluffy, roundish things on the sides of Saturn. He had no idea what they were, but eventually we realized they were rings of frozen gaseous material. Not just frozen gases, but also frozen water. So how does all that get there? Well, there's two really fascinating moons around Saturn. Titan, which has liquid methane, potentially a life-providing liquid surface underneath an icy coating, but liquid methane is incredibly cold, like minus 400. It's ridiculously cold. I mean, I don't remember the temperature. Like I said, I read it 5 minutes ago, so I've forgotten it all. But then there's Enceladus. Enceladus is spewing ice from ice volcanoes into the ring system, rebuilding the ring system every day. So every day ice falls into Saturn and becomes part of the atmosphere, and the rings are being destroyed, but every day Enceladus spews ice crystals from a volcano made of ice, well, it's like 7 volcanoes made of ice, into the ring system. And so as Enceladus goes around Saturn, the sun pulls it this way, Saturn pulls it this way, and it's pulled back and forth and back, and this gravitational stretching causes the ice on the bottom of these massive, massive glacial systems to melt. And the melted ice is very, very hot compared to, it's frozen to you and me, but it's very, very hot compared to the surface of Enceladus. And so the ice melts its way through Enceladus, spews out into the ring system. Some of it lands on Enceladus, building up mountains, and they look exactly like a shield volcano. They look exactly like a volcanic mountain chain, and that's what they're volcanic mountain chains. They're just really, really cold blocks of ice that are in the shape of mountains, and it's just one of the coolest things we found. When Cassini orbited Saturn for years, Cassini was on its way to Saturn, and for years it went around Saturn, and then its final mission was just dive into the atmosphere. It was destroyed in like 90 minutes. The atmosphere is so horrible. But Saturn, the ring system, it went through the ring system, it went around the ring system, it went over the North Pole and saw that the wind patterns make this perfect little hexagon at the North Pole of Saturn. You gotta watch how the universe works. I think it's the planets episode I posted. It's all this stuff about Saturn and all its bizarre characteristics. It is some really cool stuff. And so Enceladus is going through the ring system, spewing ice into the ring system. The ring system is made of mostly icy material. And Cassini deliberately, when they saw these volcanoes from a distance, they deliberately changed Cassini's missions. One of his 980-something missions was changed to fly through the gases being spewed by Enceladus. And so it goes through these plumes of volcanic material, which is actually ice. It's frozen water and frozen methane and some bunch of amino acids and other chemicals important for making life. And they found out that if Enceladus can get to a high enough temperature under those glaciers, where all that warmish, it's still freezing water, but it's warm for Enceladus, where all that warm material is underneath those glaciers, there is the possibility of life, because there are amino acids and there are essential chemicals for making the building blocks of life, for creating proteins, for creating cell boundaries, cell barriers, you know what I mean, cell membranes. I know the word. I do know the word. And Enceladus could have life down there somewhere, and it would be extremophile. It would be extremophile life. Extremophiles live in the most extreme circumstances, but bacteria could manage to live in those cold, cold, cold temperatures as long as the water is liquid. And it is, because it's spewing out of the volcanoes. And of course, as soon as it hits space, boom, it's a solid, it's rocks, it's little droplets of water that turn into ice crystals and then float around those ring systems. So Saturn, really amazing, fascinating things going on there. And again, I said Titan is also liquid methane covered moon on around Saturn. There's another 80-something moons around Saturn. I don't know most of their names, but they're definitely named after Roman and Greek mythological characters. So Saturn, Jupiter, Saturn, I'm pretty much going to close it there. I'm going to do another video just for Uranus and Neptune and Pluto, and I'll probably spend most of my time on Pluto, because Pluto is just our favorite little planet. Anyway, I'm going to call that one good. Jupiter and Saturn, that's it for this one.